Welcome to the Refrigeration Podcast and CO2 Mondays. I'm your host, Trevor Matthews, and today I got a bunch of special guests. We're here at the AHR Expo 2023. My good friends, Advanced Refrigeration Podcast, Brett and Kevin, hanging out with us here, and a legend in the industry, Charlie Cunliffe. Charlie, how you doing, brother?
I'm doing all right for an old guy.
And well, I've heard lots about you. I've watched lots of your videos. I'm excited about our conversation today because this is something that I hear time and time again. Technicians want to understand microthermal controls more, as well as the high pressure valves and the bypass valves. And this is what we're going to dive in today. But what I want you to do is I want you to do an introduction to everyone, let everyone know who you are, what you've been doing, and get to know Charlie a little bit.
Okay, thank you for that, and hello everybody. Thanks for joining us today. And just a little bit about myself, real shortly. I've been in the HVACR industry for over 40 years. 32 years ago, I joined Sporlan, now part of Barker Sporlan. And then about 14 years ago, I took a transfer over to Micro Thermo when we acquired them. And I've been supporting Micro Thermo and Sporlan and Parker during that time. I've gotten quite a bit of experience, especially with CO2. We've done as a division over 300 CO2 installations in greater North America. I've been involved in about 36 or 40 of those installations, and primarily I'm an application sales engineer specialist, but I know enough about Micro Thermo to be dangerous and to put on classes and to do some mentoring, which is primarily what I'm doing now. I do go out in the field from time to time, but mostly I'm involved in education and mentoring for Parker, Hannafin, Sporlan, Micro Thermo.
Yeah, that's what I love about it. There's so much knowledge that you have over the years. And I seen the growth of Micro Thermo. First time I seen Micro Thermo was 2005, probably 2006. It's the first time I worked on that controller, and it has evolved over the years, and it continues to evolve, which is great. And I remember way back when CO2 started in North America up in Quebec, that the first rollout was with Micro Thermo on the CO2 Store. That was the first platform here in North America, really, that I've seen with CO2 application. Let's talk about the development over the years as you've seen it, because you've seen the start of it with CO2 and its growth. You've been involved in many applications. Talk a little bit about that growth of microthermal for CO2.
Okay, I'll talk about that briefly, and then if you don't mind, I put a couple of slides together that I'll share with everyone. Yeah. Because it took off in Canada, it gave us, at least in greater North America, a leg up on controlling and understanding CO2 used as a refrigerant. And I'll be bluntly honest with you, being an old valve guy, when CO2 first, made it to North America, I was a little hesitant about CO2, about the pressures that you had to deal with, about the point, when CO2 does cross the critical point and becomes a transcritical fluid. All of that was concerning to me, but I've got to tell you, with my experience with Micro Thermo and controlling CO2, it has made me a believer. It truly is a way to go in terms of refrigeration, in terms of being responsible to our environment and being more cost effective if you set it up properly, and use the right hardware, use the right software to control it. Really, I guess one of the things that we had to wrap our heads around, just a little bit of background here, pressure enthalpy chart. An old timer like me, I'm used to the refrigeration cycle primarily existing inside of the PE curve for whatever refrigerant we were using at the time. When we started using CO2, obviously because of its critical point and its thermodynamic characteristics, we found ourselves going outside of that curve, as you can see here. So if you follow the line from 1 to 2, that's a line that we saw not as exaggerated at that. But if you look at line 2 to 3, We're not doing any condensing at that point because it is a supercritical undefined fluid. Yes, we are rejecting a lot of heat, but we're not changing the phase. We're not going back to liquid CO2. And then this was, something that we had to learn as we went from 3 to 4. We were actually trying to do some expansion to get the CO2 back under the critical point. And here at point 4, you see we go either left or right. We were responding to things that we learned in the field, things that we learned from our OEM partners, with the introduction of the flash tank, booster systems, interstage cooling, liquid injection, et cetera. We were doing a lot of things with CO2 that we weren't doing, with standard refrigerants. And then to get us back into the normal refrigeration cycle, 5 to 6, expansions, 6 to 7, we're picking up heat, so on and so forth. So that was the thing. Again, it was a learning point. We found ourselves, we think, ahead of the curve because in Canada, CO2, took off so rapidly and so early. But again, working with contractors like yourself, the guys that are joining us today, we learned a lot from the technicians in the field, and we learned a lot from our OEM partners. So what we did is, at the time, we had the 500 platform. And what we tried to do is reconfigure and repurpose the 500 platform to handle the challenges of CO2. So in terms of evolution of hardware and software and control algorithms, what we did is we created, using the 500 platform, the TC rack node, which is still in use today, even though we've gone to the 700 platform. We also came up with the DT secondary cool for CO2 and CO2 defrost, again, using the 500 platform of hardware. The MT331P, which is really a smart node. It doesn't have the relays and the IO on it, but we found a need more processing power. So we used a lot of the 331Ps, especially on the early installations. And then the MT5XX, whether it was a 500, 504, 508, 512, we did with our OEM partners a lot of EMPC work. And what that does is that kind of jailbreaks the hardware and allows us to do custom programming with the OEM to meet the challenges of CO2. Very early on, we knew we were going to have a more powerful and more robust platform because of the amount of information that we were dealing with CO2 applications. So that really gave us the emphasis to introduce our MT700 platform. And the very first device we came up with was the case controller. And then, of course, the rack and circuit controller, followed by the valve controller, the gas cooler node, and then the EV flash tank and gas cooler valves. And then when I log into a lab site for you later on in our discussion, I'll show you how we found a way, because of the power of the 700 platform, we were able to merge the 2-valve controller into a gas cooler train, and to be able to give you an off-the-shelf, so to speak, solution for controlling those two very critical valves, the gas cooler valve and the flash gas bypass valve, which are critical to make a CO2 refrigeration system work. I may be, being a little bit too simplistic, but the one thing I had to wrap my head around, early on with CO2 is it's nothing to be afraid of. It operates in the subcritical mode the same way that any refrigerant system works, whether we were using, 404A or an old timer like me, 502 and 22, except for the point where the CO2, crosses its critical point. And then, of course, your pressures are much higher. But once you wrap your head around that, and then the OEMs have certainly been able to, design racks and piping to withstand the higher pressures of CO2. Again, other than the pressure, it operates exactly the same as a DX system would, except for the pressures being different. I'll take a moment to catch my breath and see if you guys have any questions.
So what was that turning point for you? Because you just said that when you first heard about CO2, it was like kind of iffy, the high pressure, but was that the turning point really when you got onto that enthalpy diagram and realized that, when you're below that 87.7 mark, that it's just a standard DX system? Is that when it started to click?
For me, yes. I mean, and it took the fear away from me personally as a technician, and as a sales engineer. Once we figured out how to use CO2 safely, then we just had to figure out, okay, what do we do to get the CO2 back underneath the curve and get it to operate, the way DX systems have been operating for years.
That's why now there's so many different, high ambient strategies, right? You have abatic cooling to kind of combat that. You also have newer systems out like the SkyCool system that basically rejects some of that heat to bring you under. So you're running in subcritical, or at least not transcritical as much as the time. So now that allows us to actually start putting a lot of this transcritical stuff in the lower part of the states.
Yep. I think that was, Brett, absolutely correct. I mean, in the very beginning, we thought, oh my goodness, you could never do a CO2 system south of the Mason-Dixon line. And that's blatantly not true. I did my first transcritical system down in Southern Virginia, and we weren't even using adiabatic, gas cooler / condensers at the time. It was strictly air to air. And because we were doing a lot of heat reclaim with it, we could see that most of the time we were still able to keep that system functioning as a subcritical refrigeration system.
Awesome. So what type of controls that you have? I see the MT742 is, what options do you have for the gas cooler? So it's MT742, and I know you mentioned you guys can control them two different ways. Is that correct?
Oh my goodness, I think it's more than two different ways. Yeah. So what I'm going to do, my colleague Chad set up a lab for me, which I'm going to jump onto in a bit. Awesome. And I'm going to isolate just those two valves and show you the off-the-shelf way of controlling those two valves. And then if we have enough time, I'm going to jump to a refrigeration system where the customer has allowed me to jump in, and you're going to see an OEM using a combination of 500 platform and the two valve controller in concert. So there's I'm going to say at least a half a dozen ways to skin a cat. Again, we wanted to come out with the gas cooler node that incorporated the 2 MVC in it, so that you'd have an off the shelf. But as you know, OEMs, they take our product, and through the MPC and the MT700 EMPC, the enhanced MPC, they continuously every day do new and innovative things with our hardware. So one of the first things we did, even when we were just using the 500 system, we came up with the case controller. That was the very, very first CO2 specific node. So it's optimized for CO2 control, but obviously now we can control any refrigerant that's out there. We also have a version of it for stepper valves, which is the original version, and we have the new version for those who want to use pulse width electronic expansion valves. But again, smart fan control, true pressure superheat control, and or case temperature control. So the 700 platform was first introduced with the case controller. Those early systems, Trevor, was predominantly on the rack side, mostly 500 platform boards, and you'll still see a ton of them out there. And then the case controllers we were using because at that time there was no mechanical valve that could operate for CO2. So if you wanted CO2, you had to use an electric expansion valve.
So Charlie, I have a quick question about the MT700 train that controls the case controller. So a lot of now controllers out there, a lot of evaporators out there in the big commercial space, you know, they now implement a 0 to 10 signal. Do those case controllers now have that capability to do that?
Just this device here?
Yes, sir. Yep.
Yeah, that I'd have to get back to you. I've not done any 0 to 10, Brett. So if someone could just send me a quick note on that, you know, I would probably defer and use a regular 700 train if I was going to use a 0 to 10 input, because this is still looking for, this case controller would be looking for direct input landed on it from the 3 or 4 sensors, the pressure transducer, and then of course the valve itself. So if somebody can send me a quick reminder on that, I'll definitely get back to you and get back to Trevor to find out about that.
Awesome.
But the one thing that we found we had to do when we had a pulse width valve that we had confidence in, because really between us friends, that's really a glorified rapid solenoid, even though we call it an electric expansion valve. We wanted to make sure that we had one that was robust enough that would last, and also give a stable linear performance that a stepper valve does. And we now have that. We introduced it at AHR, I think it was 4 or 5 shows ago, but the Sporlan Parker PWM, we have a Micro Thermo case controller for that. So the thing we did then is after the case controller, what we did, hopefully you can see my cursor here, the big step forward, this is showing a 722A. The new version is the 722F. And what we can do with this train is we can have the brain, and because this brain is so much more powerful than the original 500 platform, I could actually put another 10 nodes connected to this one brain. Okay, let me just not get you seasick here, but going back to this, you'll see the 504 on the left, the 508 on the left, and the 512 on the left. That was the microcomputer, okay, yeah, or the smart section of the 500 platform. We were limited on the amount of UI we could have, on the amount of relays, but with the advent of the 700 platform, again, that 722 brain is so powerful. We can add another, you know, 10 nodes onto it. And one thing I feel I have to point out, I think Kevin is with us today. There's inputs that we philosophically feel we need to take as direct inputs landed onto the train that's controlling the rack, where there are other modalities that you could take it from another board or you could take it globally. We just feel philosophically that we don't want a chance of any kind of interruption, loss of comm, or you know, have any way that a critical pressure or temperature that we need for rack control on CO2 is not directly landed to the train. So that is one thing that's different with Micro Thermo. We think it's a positive thing. I'll leave that up to discussion for the technicians. But again, we like those inputs to be landed directly to take instantaneous real-time reaction to them with the train. So again, so what did we develop? We developed the rack and circuit controller, the 2-valve controller, the gas cooler node, and then we combine the features of the 2-valve controller with the gas cooler node, so we could have an off-the-shelf solution. So again, very simply, a schematic of what's going on. We're coming out of the discharge. We might have a three-way heat reclaim valve. That's for another class, but we're going into a gas cooler. So the magic happens with how we control the gas cooler valve and the flash gas bypass valve. Another slide on that, again, to give a look-see in it. Really, back in the days, we would call this the receiver, and an old timer like me would be used to an A8 valve or a Sporlan valve here, and a Parker A9 or a Sporlan valve here, and we would be constantly making sure that we're keeping minimum conditions in the condenser so that we could operate at low ambient situations, and that we would be keeping minimum conditions in the receiver so that we wouldn't lose the refrigeration effect in low ambient situations. Well, that is still true when it comes to CO2. You can't just focus on, okay, my goodness, what do we do when CO2 becomes a supercritical fluid? But we also have to remember that 95 or 97% of the time, the system is going to operate, subcritical, and it's going to operate in low ambient conditions. We have to be mindful of the fact that, hey, we need to have minimum condensing conditions, and we have to have minimum conditions in the flash tank or receiver so that we could not lose the refrigeration effect in low ambient conditions. So in the transcritical mode, we have two-phase CO2 entering the flash tank. What we want to do is we want to get as much of that CO2, enhance it to go back thermodynamically to 100% liquid, but any vapor that is left in the tank, we don't want that tank to become vapor bound, and we have to, again, get it out of the tank. So that's where we use the flash gas bypass valve. I'm going to say 99% of the time, that's going to the medium temp part of the rack. And what we constantly are doing is we're evacuating or pulling that flash tank down to get that vapor out of there. And again, we're taking a pressure drop across the gas cooler valve to try to enhance or affect the CO2 to become a 100% liquid, to leave the transcritical fluid stage and get back to being 100% liquid. Now, when we go into the subcritical mode, we're having mostly liquid CO2 entering the flash tank. Any gas would be vented, to the suction of the medium temp using the flash gas bypass valve. But again, we also want to maintain 100% liquid CO2 and get as much subcooling as we can. And again, I'm a guy that believes in being totally truthful. Back in the day, I would always say I would look for 10 or 12 degrees of subcooling in a normal refrigeration system. One of the challenges with CO2 that I have found, and maybe as technicians, you can tell me what you found out there, but in a good operating system, if we can get 3 to 4 to 5 to maybe 6 degrees of subcooling of the CO2, that's about the best I think that we can get right now as an industry, which means you must be mindful of your downstream piping and insulation. So again, you don't want the pressure or friction or what have you getting that CO2 to wind up getting more to its saturated condition, and then we start having flash tank in liquid, in the liquid lines and in the evaporator, and then of course we're not doing any refrigeration effect if that happens.
Yeah. So let's go back to that screen just for 1 second. So I see on there you have, and we may dive into it, you got a high pressure transducer.
Correct.
A temperature probe that looks like it's at the Like the so you're taking the ambient air. Is that the sensor for that one?
Yeah, well, this is a very simplified. I hope to show you when when I log into the lab. I think we use about 7 or 8 inputs.
Okay.
There's a ton of inputs. We have ambient air, we have entering air, we have gas cooler outlet temperature, we have the pressure in the drop leg, the temperature in the drop leg, the liquid level in the flash tank. Of course, the conditions occurring in the line going through the flash gas bypass valve. So I'm comfortable saying off the top of my head, there's at least 6, 7, or 8 inputs that we're taking. This is a very simplified, version of the inputs for that.
So are all those inputs going back to this controller? Say the what did we say here? The 742 MT 742 is all those inputs going back to that controller, and they're thinking about them and then adjusting the valve at that point.
Right. What I'm going to show you that Chad set up for me, they're all going back to the combined train, which is the gas cooler node along with the 2-valve controller merged into one train. And then I will show you when I log into another site. I can't show you everything because there's some proprietary MPCs, but you'll see that there's a gas cooler node and there's, I'll call it a freestanding 2-valve controller, and the inputs are going to various places, and then we're sharing those inputs through bindings.
And you're basically doing like 3 functions here all at once.
Oh my goodness, right? At least.
Because typically on the gas cooler, you're trying to maintain a TD, right? And then with the HPV, or as you have it labeled, the GCV, you're trying to maintain that 3 to 5 to 6 degrees of subcooling. And then with the flash gas bypass, you're also trying to maintain the flash gas pressure, which depending on your set point, depending on the schedule, 38, 36 degrees saturated, just trying to maintain that. I found that that was the hardest thing for me to really comprehend, is the fact that you have this X amount of degrees of subcooling, then all of a sudden you have the pressure drop and whoop, now the subcooling is gone. So like trying to understand that was one of the hardest things for me to actually grasp. But I think once they understand that concept, I think everything else sails as being normal DX refrigeration.
Absolutely. And Brett, that's why I said earlier that you have to be mindful of your piping because even at best engineering attempts that you make, there are times where the subcooling is just barely there, right? I'm sure you guys have seen that. And again, if you have piping where you're picking up a lot of heat, I mean, some of the stores that I've been involved in, ye gods, the run going out to the front of the store is hundreds and hundreds of feet. So I remember early on where some stores weren't really as careful with the piping. We wind up with, 10 cases, and the 9th and 10th case was getting nothing but vapor into the evaporator and not getting any liquid CO2. So you still have to be mindful. It's not, again, like, 404A, where you had 10 or 12 degrees of subcooling. Again, if you're getting 5 or 6, you're getting a lot.
Love it.
Okay, so this is the 2-valve controller, which is incorporated into the gas cooler node, but it has other uses, if you don't mind me telling about them. Yeah, we've got OEMs using this for defrost valve controls. We have OEMs using this for heat reclaim control. And we also have folks that are converting the A8 and A9 valves, which I still get calls to this day. Hey, Charlie, how do I set these valves again? Do I do the A9 first and then the A8 valve, or is it the other way around? Well, we actually have a Sporlan kit that allows you to take a mechanical Parker A8, A9, put a motor on it, turn it into an electric valve, and now you can have an A8 or A9 valve or a CDS valve controlled as a head pressure valve and a receiver pressure valve.
Yeah, you guys can go check that out on Chill Skills or on YouTube. I've seen a bunch of videos from you guys actually doing that conversion.
Oh, okay, cool.
Yeah. So you guys have that conversion, so it makes it so easy when you get the videos like that.
Yep.
So Charlie, I have one question about that control. So, you know, a lot of OEMs, they have independent controls that can talk to a lot of different BMS systems, right? I know for the most part, Micro Thermo talks on Echelon. Is there any talks of being able to use your valve train on other manufacturers because of the supply chain issues?
There's talk about that. I mean, I am working with some situations right now. I can't mention the name of the supermarkets, but we find ways of using, you know, I'll say translator boards for lack of a better word. And we are working with other modalities, you know, through boards that take the Echelon signal and or COM and completely convert it over to, for instance, BACnet or 485.
Cool.
Right. I've done, I hope I don't get in trouble for mentioning their name, but one of my integrators and I did, I guess it's about 4 or 5 years ago now. And we did a lab at the Campbell Soup headquarters in Camden, New Jersey. And they were primarily using Siemens in the building, and we were able to install a third-party board so that everything that we were doing to control the CO2 system in their laboratory was completely visualized real-time through Siemens. So it can be done. It can be done. Now, one thing that I do want to mention, however, with Micro Thermo, the boards are self-operating. They are not standalone. Let me try to explain what I mean by that. You would still need to have a Micro Thermo front end to purpose and integrate the smart node and the train, if you're following what I'm saying, all right? If there's no screen or input on the train where you could do that in the field, you would still have to purpose and integrate through the Micro Thermo front end. Once that is done, Micro Thermo smart nodes become self-operating and do not require the industrial computer that everybody calls the data logger. That is not required for the smart nodes to operate. They operate you know, as self-operating controls, and they share information on the Echelon network and go through that data logger as your outlet to the real world. So we really like to call that an HMI, human machine interface. And that's your ability to interrogate the network and see what all of these smart nodes are doing, and they're sharing information with each other. Now, the valves that Sporlan has made for CO2 are the gas cooler valve GC10 through GC50, depending upon the size of the system. And for flash gas bypass, the FGB60 and FGB70. But I'm here to tell you that OEMs are using other Sporlan valves. For instance, the site we will go to later, hopefully if we have time, you'll see they're using SVR valves in place of the FGB flash gas bypass valves. So these are the valves that we have off the shelf to do the function of the gas cooler valve and the flash gas bypass valve. But don't be surprised that OEMs are using other Sporlan valves to do this. Now, I should mention that we also can monitor third party. There is, you know, a Danfoss setup, you know, that's out there. That's used in some of the earliest systems that I have done and is still used today. And we can monitor and we can visualize exactly where the valves are in relation, but we can't control that because that is proprietary and requires a standalone Danfoss controller, but we can visualize that and we can monitor. But we think it's a cleaner setup if you use the Sporlan gas cooler and the flash gas bypass valves directly with Micro Thermo and use the 2-valve controller for their operation.
Are you just using a feedback loop from the 326, the Danfoss controller that you're talking about, in order to monitor that?
Yep. We're
Okay.
using analog, to monitor where it is. But again, Brett, the thing is, I've got to say though, where in Micro Thermo, I can push a valve open and closed, I can override the valve. Obviously, when it's third-party, standalone, proprietary, that takes it out of the picture. So I always feel that it's safer to have a valve and controller that's fully integrated, so that you could do what you need to do in terms of bypass and and any type of fixed value that you want to lay in temporarily. That can only be done when it's a fully integrated. Hey, Trevor, I see in my dashboard, there's a chat. Is there someone that's been trying to ask a question for quite some time now?
Yeah, just they want to know more about the MPC controllers.
Hey, thank you for watching this video. I do hope it's bringing you a lot of value. If you're interested in learning more about Refrigeration Mentors training programs, education programs, and mentorship programs, head to the refrigerationmentor.com website. We build supermarket refrigeration programs, CO2 refrigeration programs. And if this is something that interests you, click on the contact us button and let us know how we can build a program that works for you and your organization. And let's get a conversation going.
Wow, we could do a whole session on MPC, but just to give an explanation, when we talk, I'm going to try not to get you seasick here. Let me go back. Okay, the 500 series. Let me talk about this with MPC. When we set it up, we have certain profiles. You can set it up and say, okay, it's an HVAC. What am I controlling? A condenser. I'm controlling a rooftop. We can set it up for lighting. We can set it up for monitoring and controlling energy. And by that, I mean load shedding. When we do that, we purpose the inputs and we purpose the relays, okay? And they don't become movable. Now, the idea with that is a standardization, right? It's not we're trying to clamp down or like hold you back in terms of what you can do with the controller. But one of the things that people love about Micro Thermo is you can really do so much with it. You're not locked in, but the danger is if you do all of those individual things and you don't keep a record of what you did, how does the next technician know when they get to the site what you're doing with the 508? Or the 512. So what the MPC does, it allows you to open it up and you then purpose what are the universal inputs used for, what are the analog outputs used for, what are the digital used for, et cetera, et cetera. And it allows you to customize the 504, 508, or 512 to do what you need to do. And you do that through block programming, so you don't have to know how to write code. If you can draw it on a sketch pad, if you can visualize it and draw it on a sketch pad, you go to the MPC and it gives you a palette, and then you're pulling down universal inputs, you're pulling down PIDs, you're pulling down, sequencers, et cetera, and you're actually collecting lines. Okay, this output goes to what input, goes to a sequencer, goes to a switch. So like I said, if you could visualize it, if you could put it on a sketch pad, you can actually do the visual programming and completely purpose one of the 500 platforms. Now with the 700, we have the EMPC, or the enhanced MPC, which is in, oh my goodness, stages much more powerful than the original MPC. And that's because of the power of the 722F brain is so much more powerful, and because you can mix and match the nodes that you can put in a train. Imagine this, you got the 722, and then I can add 10 more nodes onto that. Yeah. So now when you jailbreak this and you use the EMPC, you have, ye gods, all kinds of inputs, all kinds of relays that you can purpose for what you want to do. But the cool thing is, if I had to do this with 10, 11, or 12 500s, guys, you know what happened. I needed 10 or 12 power landings. I needed 10 or 12 echelon landings. I needed to do 10 or 12 service pins to integrate all of that. But with the 700 platform, look, whether I have 2 or I have 11 nodes, there's one network connection, one power connection, and squint real hard, there's the service button right there. That's how we integrate. We don't have to do any jumper wires, or we don't have to do any dip switches, but you push the service pin, you release it, and then automatically the integration is done for you. But now I don't have to do that 10 or 12 times over. I have to do it once. And then it integrates programs or flashes the program and all of the set points onto that train.
Which makes startup and commissioning so much easier instead of having to commission 40 different boards down the train all over the damn place.
Oh my goodness. And it cuts the price down too, Trev, excuse me. Who is that? I lost the voice again.
Brett. It was
Brett, sorry about that. Absolutely, Brett. It makes it less costly. It makes it faster, and it's way less nodes because no matter whether you were using a 500, a 504, or all the way up to a 512, what were you left with? You had only 8 universal inputs. You could not get any more. And now really the sky's the limit when it comes to the 700 train. The sky's the limit with that. So there's so many more things, less real estate, less network wiring, less power connection, and then programming it. And again, with the delayed install. Now, truth be told, if you were integrating and flashing the program for 11 nodes, who wants to sit there for 5 or 10 minutes and watch all of that stuff load? So what we do is a delayed install. What that allows you to do as a technician, I run around the store with my tablet, my Android tablet, and hopefully I have good internet signal at the store. But what I'm doing is I'm going from case to case to case. I'm going down the rack, etc., and I'm just doing the initial integration. So what happens? You push the service pin, and you see the handshake. You see a few exchanges of data of the data logger acknowledging, okay, this is the gas cooler node, and then there's a handshake there, but you don't have to sit there and wait for that all to program. You could if you want to, but who's got time to do that? So the last thing you do when you leave the shop, you go into the delayed install, and then you let Micro Thermo integrate itself overnight, and you don't have to sit there and watch the screen. And get this, when you get to the store the next day, you open it up, and if Sparky took the power away and we didn't get a complete load, it'll tell you, what nodes didn't get loaded, so you know that you had an incomplete installation. Or if all things went well overnight, everything got integrated, and you're ready to go and start, integrating the rest of the store. So that's a big time saver too, being able to do the delayed install.
Great. Why don't we jump into one of those stores?
Yep.
We still have
So
time?
what I'm going to do, I'm going to stop my share right now. Keep me on track, Trevor, as far as time is concerned.
No, that's all good, because I do the same thing. That's the trainer in you, the educator, where you just want to share unbelievable amount of knowledge.
Oh, you know what though? One thing I do want to get back to. Let me, because we didn't talk about that. Let me just talk about this. There's a ton of electric valves in a CO2 system.
Yeah.
I'd be mad at myself if I didn't tell you about this. Please have a multimeter, because the old question is it the valve or is it the controller? The first thing you want to do with a multimeter is look at the spec. Now, here's the spec for the big valves. It's 100-80, sporlan.com. But all of our expansion valves, electric valves, have bulletins. Mostly, all of them are going to fall under 75 or 100 ohm motors. So you're going to want to check white to black and you're going to want to check green to red because it's a polyphase DC motor. That's how we get the motor to spin either clockwise or counterclockwise to open and close the valve, okay? The other thing you want to do is black to earth ground, white to earth ground, green to earth ground, red to earth ground. You want to have it set up on continuity, and you better not get continuity on any one of those windings because then you've got a valve that needs to be replaced. So you want to look to see that you're within 5% of the nominal ohms, comparing white to black versus green to red. And then you also want to make sure that you're within 5% of each other. So let's just say it's a 100 ohm motor and you're doing white to black and you come up with 98. And then you do green to red and you come up with 125. Then that valve needs to be replaced because you got a phase imbalance in that valve. And the last thing I wanted to mention is to make sure, that you have an SMA12. What this allows you to do is disconnect the wires from the case controller or from the train. And again, black to black, green to green, red to red, white to white, and then set it on 200 steps per second, and then rock that valve open and closed. You should hear the motor operate, but it should not sound like a bucket of bolts, okay? And watch these LED lights. If you notice the red is very dim or doesn't light at all, then that's telling you that the red phase is bad and that valve needs to be replaced. So standard thing you should have in your toolbox when you're working on a store that's CO2, you're going to have a ton of electric valves. Make sure you have an SMA12. Make sure that you have multimeter. Okay, so now let me stop the share.
And once again, there's a ton of videos that show how to use SMA12 online. They're not difficult at all. This is, if you're in the supermarket industry, you're doing CO2, you should have a control like that. This is what we're all about. You need the right tools to do the right job as quick as possible, you know, because you don't want to spend 2 hours trying to figure out if the valve is bad or not when you can have a control like that to tell you that.
Absolutely.
Also, let me make one more notation about that valve, that range that you gave. Just remember that is a temperature based.
Oh, yes, good point.
Value, that resistance value will actually change. And the other thing about checking the actual that bipolar stepper motor, yes, you did say to make sure that you check each one of those legs to ground, but also where each one of those independent windings are, make sure that those wires aren't. So you said it's supposed to be black and white and red and green, correct?
Correct.
So make sure that black does have no continuity to your white, because otherwise that's also an internal failure on that valve as well, which can actually happen.
Yeah, and those are wet motors, so we don't like them to be run too much without refrigerant in them. And also, as with any valve, you want to make sure that you definitely quench that valve when it's being installed, because you don't want to compromise the insulation on the wiring going to each of those phases of the motors. Let me stop my share here and see what's going on.
So put water on the valve then, Charlie?
No water on the valve, but either use a heat lock or at least on the body. A wet valve on the body of the valve, not necessarily on the motor, but if you overheat the windings, if you overheat the wires, you can compromise that valve. Let me see what's going on here.
Yeah, and that's one of the biggest things. I've worked at manufacturers of electronic valves, and I talk to everyone, and 98% of the time, 99% of the time, it's field-related issues, install, overheating it. Oh, I didn't overheat it. But when it gets back to the manufacturer and they inspect it, it's all burnt up inside because they don't look inside. And I've seen this time and time again. Or there's dirt jammed inside. No, there's no debris at all. But when they cut it open, look inside, all jammed up. So a lot of user error for electronic valve failure.
Yep. Okay. Can you see this now?
Yes.
Okay. So let me just make sure that I'm logged in for a good amount of time so we don't have any interruptions.
You know, someone's just going to log into this and kick you out. You know that, right? While we're doing this.
Well, no, see, that's my colleague, Chad. What he did is in his lab, so that we wouldn't have sensory overload, because when I go to the live site, there's going to be so much information on the screen. What Chad did for me is it gave me a blank palette and just has the gas cooler node by itself, so that we can concentrate on this gas cooler node alone. So I'm going to open that up for you now.
Shout out to Chad Bartley.
Yeah,
Thanks,
yeah. Okay, all right, so this is the basic landing window for the MT 700 platform, and
Awesome.
all of the information you needed with the 500 was there. But if you weren't a frequent user of Micro Thermo, you might forget where to find it, okay? But the great thing that the engineers that designed this did is they put all of the information in common areas. So with the 700, some people call this the sandwich or the hamburger icon. I say it's the library stack of knowledge. Whenever you want to interrogate 700, you always go to the hamburger or the stack of knowledge right there. That's where you go to.
Stack of knowledge. Let's go. With that.
Okay. All right. So let me first go to the IO assignments so I can show you what's going on here. Trevor, can you see this good enough on your
Yeah,
screen?
it's beautiful.
Perfect. All right. So what we have done to give you an off-the-shelf solution is the 722 is so powerful, okay, that we have a train. It's a very short train for this example, but there's the brain. And we're taking gas cooler outside air temp to this input. We're taking gas cooler outlet temperature, all right? We are also taking the variable speed fans to this input, okay? Or analog output, excuse me, is coming from here. And then when you see something green in Micro Thermo, that means that that is not purposed and it's open for you to use,
Great tip.
all right? Okay, so that's the brain, the 722. Let me move forward. Now, this is the MV. This is the multi-valve controller. So what we did is we programmed a way where this can be integrated into the gas cooler. And we're not using any of these inputs right at the moment. But right here, we've got the gas cooler outlet. And then we also have the flash gas bypass valve. All right, and then let me go on to this mode here. Now you see this is much more purpose. This is the UI A04RO board, the 766A, and on universal inputs on the bottom here, we have drop lake pressure, we have discharge pressure. UI3 is not purposed. We have receiver pressure. Okay, now we have receiver liquid level low. Okay, coming in. We have dry fault coming in. This is not purpose. This is not purpose. Now let me go to the relays up top. Relay 1 is open and ready to be used. Relay 2 is ready to be used. And what do we have here? We've got this being used as a bypass relay and this as a reset relay. So again, this is not a full gas cooler node. This was done just for conversational purposes. But this is, so we have a node ready for you that's off the shelf to control the fans in the gas cooler, okay, and the temperature, therefore the pressure in the gas cooler, and also control the two valves. So now let me go into this first, the gas cooler right here, and with 700, again, whether it's the compressors or what have you, you always go into configuration. So what do I have configured here? For control, we have gas cooler, all right, and we're doing the variable to regulate. For this choice, we're doing outlet temperature, and for this instance, Chad set it up to be floating. We also can do it for a fixed value, but as you know, the industry goes today, everybody wants to be able to do floating. Now, the float set point, again, either get these from the engineer or the OEM. This approach set point could be anywhere from 5 to 10, all right? Then you're also going to want your minimum and maximum outlet points. So this one, Chad set up for a minimum of 55, a maximum of 8. And what we're doing through the pressure, we're having a calculated temperature for control, which is 60.7. If anything were to happen to any of the inputs, then we also have a fail-safe. We have a fixed set point if the outside temperature ever becomes compromised or invalid. And right now you see it's 60.8.
Yeah, and that's perfect because stuff does happen. You know,
Yep.
Sometimes something gets pulled, something gets damaged, or something fails. And then
Right.
At least that gives you some time to get another probe to get your system up and running.
Yep. And then there's an alternative set point. If ever the condenser or gas cooler outlet temp becomes invalid, then we have a fixed point that we will control to. You'll obviously get an alarm that we've lost that input, okay? But it's not going to crash the system because we'll have a fixed point at least so that the system will continue to run, okay? Here's where the staging information, okay, this one is set up simply, one analog output, okay? All right, and your minimum, maximum capacity is 33% for your VFD, 33% for the min, and 100% for the max, all right?
Yeah.
At the same time, we also have pressure limits that are there as backup. So if at all the pressure ever goes above 1200, we're going to run the gas cooler, all fans, pedal to the metal. We're going to just artificially run everything to the max, and our signal to go back to normal conditions and operation is what Chad has to set up here for 1055. Now, again, bear in mind, these are for conversational points.
Yep.
That doesn't mean the system that you're going to work on is going to have these set points, but we encourage you to work closely with the rack manufacturer
100%.
to make sure these points are applicable.
So is that controlling the HPV, or is that controlling the condenser control in case that would get too high?
Yep, this is the condenser fan control.
Okay, so all right.
Okay, so again, the thing with this gas cooler, Brett, is why some manufacturers are still keeping it separate, because you have compound things going on, right? You've got it controlling the gas cooler and looking at the gas cooler and controlling the condenser fans, all in that same train.
Yeah, because for the most part, it should just be trying to control TD, right? So
Right.
it's just going to go as high as whatever the ambient is. So whatever the ambient is, plus your differential. So in this instance, it would be 5 degrees. So in this instance, if you just so happen to be in sunny Texas, where it's 110 degrees, it's going to be trying to control 115 degrees saturated.
Okay, and then the other place you need to go when you're setting it up, again, for the off-the-shelf, you want to go to this stack of knowledge here for receiver. Again, you go to configuration. And now here's your gas cooler valve. What am I doing? I'm doing control of a stepper. My subcooling target is 5 degrees. My transition region, Chad has it set up for 10. Now, go to 100% heat reclaim demand, okay, 1523, and the set point, the nominal set point for all of the evaporators in the store, 18 degrees, all right? And heat reclaim set point. Now, internal means that that information is being fed directly back to this train, or when it says it's external, that means that that input is coming from a node somewhere else on the network. I hope I'm being clear on that. Some of the language, you've got to understand what our engineers mean by that. So internal heat reclaim means we're taking the input directly to the node.
Yep.
And if it's external, we're taking it from a node somewhere else on the system. And then your gas cooler set point is 877. I should put my glasses on. Right now, we're in subcritical, but these LED indicator lights, these virtual ones, will light up and tell you, are you operating subcritical, or are you in that 10-degree a transition point, or have you gone transcritical? So you'll see that light up. Now, one thing that I did want to show you.
Let's just go back there for 1 second.
Yeah.
Charlie.
Yeah.
Because this is something important to understand about CO2 that you don't see in other systems that you talked about. We got the transcritical mode, you got the transition mode, and then you got the subcritical mode. And so now you have that subcooling target for 5 degrees. So that means that you'd be in the subcritical mode at that time. Is that correct? And what is your target from where are you getting that target from? From your ambient? So that's your drop leg temperature, making sure you have subcooling in the subcritical zone, correct?
Yeah, your targets are going to be the actual temperature. I'd have to see how he set this up, either drop leg or drop leg conditions for the CO2 and the pressure and temperature, right? So we want to keep it away from the saturation at that point. We want to keep the temperature lower, but we want to keep the pressure higher in that flash tank to make sure that the CO2 is going to be 100% solid liquid at that point.
Charlie, doesn't the subcooling targets come from the COP chart inside the controller? I thought that's all the subcooling target itself. I thought that comes from that COP chart that you guys have inside the controller.
Did you hear that question, Charlie?
I did hear that question. I don't know if Chad was able to join us. I'd have to get back with an answer on where we're taking that information from.
Yeah, and I've heard that before too, Kevin. The same thing what you just said. Just so everybody knows, then there's that transition zone where you have 10 degrees, because I think this is important. This is where you're not in the transcritical yet or in subcritical, because it would be banging back and forth. All of a sudden, your valves would be all over the place. So you have this transition zone, so it doesn't do that. Like you would have hunting, a lot of hunting.
Yep.
So you have a 10-degree transition zone. So that would be 87 or 88 degrees Fahrenheit all the way to 78. Is that correct? That would be your transition zone?
Yep. And the other thing I wanted to show you, a lot of people prefer to see this in temperature, but if you uncheck this, then you can start to see some of the, let me go to configuration, then you can start to see some of this shown in, now Chad might have turned that off, but a lot of it will be shown in PSIG. And then it's shown in Fahrenheit. Okay. I like a lot of times, to be looking at pressure. Now, in terms of inputs, I don't know if this is fully, but receiver pressure is universal input 1. So we'd have to see where he has that landed. Okay, he's using a 2,000-pound sensor for that, and we'd have to see where that universal input is coming from to see where that's coming from. When we go to the live site, we may be able to visualize that a little bit better. The other thing I wanted to tell you, we call it interlocks. I'd rather call these safeties. On the gas cooler valve, use limit based on receiver high pressure. So we close the receiver if saturated temperature reaches 50. Okay, and then we've got a limiting region, and we start limiting it at 46. All right, and then for low pressure in the receiver, start limiting it at 28.9 degrees, and then you'll open it fully if the saturated temperature ever falls before 26.4. Just the way this is set up here. Okay, now if you're not going to do that, and you uncheck it, obviously those boxes go away.
Charlie, do you want to go over the PID for the flash gas bypass and the high pressure valve, the dual settings?
I'm usually I usually don't like to go over PID because if I was doing this only for you, I would. But again, if you go in and you start changing the PID, one infinitesimal change can cause a huge, huge change where you can, send the system in outer space. I would generally, other than someone completely seasoned like you guys, I would generally like to have somebody from Micro Thermo advising the technician if they're ever going to get into the PID settings.
See, we can't take you anywhere.
No, of course we can, but you want to understand, because that's a knowledge that you need to spend years at, the PIs and the PIDs. I've worked with lots of them with the Dixell product line, and I spent years on it, and I still I feel like a novice. So I don't recommend playing with that unless you've worked on them a lot. You understand how it controls, because some are opposite, some are inverse, some are not.
And a lot of times people mess with the PID settings when they really don't have to. There's an actual system issue, and they're not fixing that issue. Rather than they're just like, oh, I could band-aid it with the PID and that'll be fine. No.
Oh yeah, right. So, I got a gain of 40 on the P. If I make it a 60, that'll be even better.
Absolutely, it'll just wear out the valve.
and then you just send everything for the highly trained technician. Again, like you guys. Sure, you could go in here, but again, my rule of thumb would be really try to have either the OEM, whether it's LMP, Zero C, Hussmann, Hill Phoenix, get them involved, or get Micro Thermo involved. But yes, good question. The PID is in there if it should be, if you need to tune it, but we generally would prefer that you not go into those PID settings.
Unless you're Kevin.
Well, hey, listen, I know from experience, Kevin, takes a deep dive into Micro Thermo and has a good understanding of it. I would feel comfortable discussing that at any time on a job with Kevin or any of you guys for sure. But we generally like to stay, even in the case controller, we like to stay away from the PIDs unless absolutely as less necessary. So, hey, Trevor, do you want me to see if I can go into a live site right now?
That would be fantastic. So, and the big thing is that you want to understand that this is the main difference between any other system out there and CO2. It is this here, the high pressure valve and the bypass valve.
Yep.
And it's so good to see it and understand that after this, everything else is standard refrigeration, standard supermarket, what you're doing. So, no, I love it. Yeah, if we can jump on, we'll stay on for a few more minutes. There's
okay.
A lot of people just sticking around. I love this. So I really appreciate everyone hanging out with us and learning. You have any more questions, Kevin, while he's looking it up?
Yeah, I just have to, looks like I've got multiple team viewers going, so I got to correct that. So let me.
There is one question while you're doing that.
Go ahead.
Does the 722F support summer and winter PID for gas cooler valves? So is there two different PIDs?
No, that's a great question. When you set it up, if we had to do it that way, and I truly mean no disrespect, but that's like going in old school and saying, hey, Charlie, what's my wintertime setting for the A8, A9 valve? And what's my summertime setting for the A8, A9 valve? What you want to do is you want to set and forget. That's the whole reason why we put the two valve controller and put it inside of the gas cooler drain, so that we could do, in fact, that we could do all of the engineering needed so that you can put the proper set points in, so that you set it once and that's it. You don't have to come back and do a seasonality setting.
Yeah, which makes sense, because when I was first in the trade, I remember going to stores. Oh, we got to add charge, we got to pull charge out. I'm like, what do you mean? There's a winter and summer charge. No, it's just not sized properly.
Okay, it looks like I'm having a little bit of a technical issue. Let me see if I can keep working on this. Maybe you guys can fill with some questions while I'm trying to get the technical on my end to work.
No, I think that is really good if we can't get that. But so one of the questions that I did have, and I think we kind of talked about it, the controller has different like knowledge capacity. So when it's in high ambient, it understands, and that's the big thing, is those 3 zones understanding. And I really like that. I haven't seen that before, the way you guys have it broken out, and it's very clear reading it on the Micro Thermo. It says it's in subcritical, transition, or transcritical mode.
Yes.
I think that's very important. What else? You did the navigation. But the sensors, this is another good question. What is the main sensor that the brains are working off it? Is it that gas cooler outlet pressure transducer? Because if you lose that there, and you may have talked about this, I just wanted to double check. I got it in my notes here. If you lose that gas cooler outlet transducer sensor, the pressure one, what happens to the valve?
Okay, well, that's why we, maybe I didn't stress that enough. That's why we have those fail-safe settings in there.
That's right. You did say that.
If we
Perfect.
ever lose those critical inputs
Yes,
for
you did say
controlling the valve, that we have that. I seem to, let me see here. I seem to be having a technical issue with my team viewer getting that live site. I'm going to give it one more try here to see if
Charlie, while you're trying to get that up, so it's the equivalency of like, okay, so because we're trying to maintain TD control, we're using the ambient temperature, right? And then we're using the drop leg pressure transducer in order to achieve that. So God forbid if we do lose the pressure transducer, that's why we also have that temperature sensor on the drain leg, just to basically be our fail safe or backup, it has to say, for it to try to achieve the same thing.
Yep.
And I'm going to add something to that is, we have to make sure that those sensors are extremely well insulated, because otherwise we will get faulty values. Some racks you'll see, they wanted a couple inches right off the actual gas cooler itself. You want to make sure that you typically wrap it first with some kind of black insulation, but then if it is happen to be outside, I would highly recommend wrapping it with some sort of reflective tape. And then what that's going to do is it's going to lessen the effect of the ambient sunlight hitting that sensor and then affecting that temperature sensor as well.
Yeah. And I do have another question too, because I see a lot of manufacturers, especially for the high pressure valve, they say they want the transducer right at the outlet of the gas cooler, but I've not seen one yet at the outlet of the gas cooler. I see them inside on the rack, unless the controller is up and outside on the gas cooler.
Yeah, and unfortunately, that's a manufacturer thing, right? Because they want it's weird because the manufacturers will tell you, like in the controllers, we want it this many inches away, but then the rack's like, we're just going to put it right at the rack. And then you don't have to run that extra 20 feet of cable.
But I think as long as you don't have a massive pressure drop and CO2 pressure is so high, I think it's not going to affect it too much. Any thoughts on that, Kevin?
The only issue is when there's a strainer on the drop leg, and the strainer starts to plug up, and then you start getting false values.
100%.
But I mean, pretty much everybody does it that way.
Yeah, I've seen dozens and dozens of stores that way. So, Charlie, if you can't get it, that's okay.
Yeah, unfortunately, it's a limitation of my lovely cable provider, which I get my internet from. It's obviously can't handle the bandwidth of everything that I'm trying to do at once, and it's just not giving me the internet connection out to the remote team viewer for the store that I wanted to go through to. I really apologize for that.
Kevin has the same problem. You got to get that Elon Starlink thing.
Yeah, no, Charlie, this has been amazing. If anybody else has any questions, please throw it in the chat. But I learned so much today, and this is what it's all about: share knowledge in CO2, getting the experts together, and this is the start of it. What you really want to do for CO2 refrigeration is start to learn it. There's so much information online. You can head to the Advanced Refrigeration Podcast. You can head to Chill Skills and Sporlan. You can head to the Refrigeration Mentor podcast that you're listening to right now. It's so important to invest in yourself, invest in that knowledge. CO2 is here. It's not going anywhere. We're going to see it continue to grow, and I'm super excited to be a part of it. And do you guys have any final questions for Charlie?
Yeah, when do we get our MT Alliance computer so we can start messing with the block logic, Charlie?
Wait, what was that again?
I said, when do we start getting our Alliance computer so I can start messing around with the block logic there?
You don't have a data logger in your office to use?
I haven't been given one yet by Charlie.
Well, me either.
Yeah, Kevin's been waiting for his real long too.
All right, well, listen, I'll have to talk to the powers that be, see if we can get you guys hooked up with that, all right?
Thank you, boss.
So I want to thank everyone so much for taking their time out of their day, hanging out with us and really learning a little bit about CO2. Charlie, where can people find more about Micro Thermo, more about you, to really dive in deeper if they want to learn more about Micro Thermo?
We have, as with, all Sporlan, if you go to our website, or you can get to it a couple of ways through Sporlan or through Parker. The great thing is all of the Micro Thermo is now fully integrated onto the Parker Sporlan website. And I think you met Dennis, who does, guess what just happened? My whatchamacallit came up. Do you want to see it before we sign off?
Let's do it.
Okay. And Dennis is starting to get some of my classes and some of my videos uploaded onto the Sporlan site. Hopefully you can see this.
Yeah. Oh yeah.
Sorry, guys, it's good old Xfinity. Giving me horrible bandwidth here. Okay, awesome. Whew. All right, so I'm going to make sure I'm in configuration. Now, what I'm going to do is I'm going to go to rack view here. And again, this is why Chad set up the information for me, just having that node alone, because look at all of the information that's on this rack screen right here. Now, not to confuse the audience, guys, this is a slightly different flavor. This is using the gas cooler node. You see it up here? I'm going to click onto the plugin. So this is using the gas cooler node strictly for the cycling of the fans, okay? All right. And at the same time, we're using the 2-valve controller so that the gas cooler node standalone and the 2-valve controller standalone are working in concert with each other. Now, let me show you something cool that I can show you on a real site that I can't show you in the lab site. So what this manufacturer did here, because they wanted to, they've got a backup. Now, Trevor, you said how important the gas cooler valve and how important the flash gas bypass valve. It was so important to LMP that they put a backup gas cooler valve and a backup flash gas bypass valve on the site.
And I'm seeing more and more manufacturers actually do that.
Yep. So now what I'm going to do is I'm going to right click on here and I'm going to do highlight connection. Now you see how that turned purple? Look very carefully up here. You see that green dot? That is to the right is the plugin, to the left is the node. Yep. So what I'm going to do to show you how much information is being fed, I'm going to do cancel the highlight. And what I'm going to do is I'm going to zoom in. Now you see that? That's the throttle valve. This is for the flash gas bypass. I'm going to highlight connection and I'm going to zoom out. Now, here is all of my inputs that's associated with both the plugin and the node that's controlling the flash gas bypass valve. Obviously, I couldn't show you that on the lab, but here is, if I hold my cursor, okay, so here's my discharge gas cooler temp value. Here's my exit gas cooler value. Here's my drop leg pressure. Here's my gas cooler valve throttling point. Here's my pressure inside the flash tank. And here's my point in time for the flash gas bypass valve. Those points, those pressures, those temperatures are all associated with that 2-valve controller right there, which in this particular setup is operating as a standalone, and the gas cooler node, excuse me, is also operating standalone to control all of the fans there. However, they're working together and sharing information together, and they're working in collaboration to control the gas cooler and flash gas bypass valve. So let me dive into this a little bit deeper. All right.
Charlie, was this done to replace the 326A?
Yes, sir.
Yeah, I was gonna say, because I've done 2 of these now at Costco, changing dead 326As to 2 valve controllers. It goes pretty smooth.
Yep, but it's a combined solution, right? So what I was showing you that Chad set me up is everything is all done on that one train. But what I have in this situation is I have a gas cooler train and everything it's doing, and then I have the 2 valve controller working in tandem. All right, so here's all of my inputs, real time. All right, so what am I taking? I'm taking, unfortunately, they try to keep it secret. So look what they do, pressure 08, temperature 05. So you have to look at the legend to see where that's coming from. But again, visually, you can see where all that input is coming from.
But that's one amazing thing too, is like that little tip there. Well, you clicked on the valve and it was purple and was only one thing purple. Well, when you went to the throttle mode and highlighted that, it showed you all the different parameters connected to it. So that's a very important, because it could be one of those 7 parameters that are sensor story that could be the issue. So
correct.
Yeah.
So here's all my inputs. Here's my outputs. So what I like about the separate is pretty nice is, look, they're showing you, okay, you've got a GC30 on this job. It's set up in radial configuration, meaning the inlet is coming from the side. All right. And look what they're doing. They're not using one of our flash gas bypass valves. They're actually using an SD4 for flash gas bypass valve, but this is actually piped axial, meaning that the input is coming in the bottom. And guess what? It makes a difference in the control of the valve and the performance of the valve, whether you're feeding on the radius of the port or you're feeding in the axis of the port. But here, valve 1, here's my individual limitations: maximum percent open, minimum percent open, et cetera, et cetera. My initialization, my lawn information, gas cooler, number of steps, 2,500, step rate. Look, they have it at 400 rather than 200. So to speed its reaction up. Let's see what they're doing on.
And this is what's really important. It's key that you go in and understand each one of these.
Yep.
You don't want to be going around and changing anything unless you know what each thing does, because if you go in and start just changing the step rate, that's going to affect a bunch of things. If you check the current, is going to affect it. So don't just start changing stuff unless you know what you're changing and why. And if you do test it, make note of all this stuff, log it. So if anybody else goes there, that they know that this is what you changed, so they can go back and put it back to those settings, because a lot of times, like Brett said earlier, things get changed and there's something else wrong in the system. So just make sure you log that stuff.
Right. So now this is a big valve, obviously, and it's got a big port, and the needle and pin have to traverse quite a bit. So it's 2,500 steps. They got a step rate of 400 steps. Now with the SDR4, this is 6386, but again, this is their choice, not mine, but 200 steps per second. What I should have shown you before, always look for these question marks.
Yeah.
I should have showed you that in the laboratory, because when you do, look at this. Now you don't have to go out or open up your smartphone, but our engineers have tried to think of everything you might need to know to understand what is the method of our madness for how we're helping control this valve.
That's your education right there.
All right. And again, here's the FGB. Go to the magic question mark. And again, what are we doing?
I love that. I love that. Charlie, this has been amazing. There's so much knowledge that we share. I could spend another 3 or 4 hours, but I want to thank you for taking the time to show us all this. And I know I'm going to have you again on the CO2 Monday podcast, because this has been amazing. There's just so much knowledge that you have. I really appreciate your time. Brett, Kevin, thank you so much for taking the time to do this. And thanks everyone for taking time to listen.
Hey, thank you for watching this video. I do hope it is bringing you a lot of value. If you are looking to grow and build your refrigeration teams and want them to learn CO2 refrigeration, head to the refrigerationmentor.com website, click to contact us, and let us know how we can build a culture around training inside your organization. Let's get a conversation going.